Section 1.3 is functions. So all of us know the definition of function. We have studied in the first year of BSc or and second year of BSc also. So let us recall what the function is and what is the Cartesian product is. So the first definition, Cartesian product. So let us suppose if A and B are sets, then the Cartesian product of sets A and B is the set of all ordered pairs A comma B, where the A first small element small a is from A and small b is from B. That is how we can write. We denote the Cartesian product by A cross B, and the elements of the set A cross B or Cartesian product of A and B is collection of such kind of elements A comma B, where the first coordinate of the Cartesian product, first element of the order pair is from first set A, and the second element from the order pair is from the second set B. So this is the Cartesian product of two sets A and B. So for example, let us see some examples. Suppose we consider set of real numbers. So let A is set of real numbers, B is set of real numbers. So the Cartesian product A cross B will be R cross R, will denote set of all order pairs of real numbers, is a set of all ordered pairs of real numbers. That means we can write this as R cross R to be collection of order pairs x comma y such that x is real number and y is real number. So x and y both are real numbers. So it is nothing but a plane, right? The second example can be, suppose if we consider set A to be a line segment and set B to be a circle. Then the Cartesian product A cross B. What can be the Cartesian product of a line and a circle? So if we move the line along the edges or perimeter of the circle, or if we move the circle along a straight line or a line segment, so it will look like a cylinder. So it is a right circular cylinder. Now let us see the definition of function. So we have seen in our first year and second year class the definition of function. So we have two sets A and B. So you may remember there is a concept of domain, codomain and range of a function. So let us recall the definition of function. So suppose A and B be two sets, then a function f, then a function f from A into B is a subset of the Cartesian product A cross B. The Cartesian product A cross B. But the restriction is that with the property that each element of set A belongs to precisely only one pair A comma B. So if we write the order pair xy belongs to F, where F is subset of A cross B, the order pair x comma y belongs to F means y is equal to f of x. Therefore, y is called the image of x under f, under function f. And so this is similar to our definition of function. What is the definition of function? Generally, we define f from A to B is a function. This is our definition of function we have studied in the first year and second year. Is a function if for each x belongs to A, there is unique y in B, such that y is equal to f of x when this x is from A. So this is the definition of function. This is nothing but some other version of the definition of function. So order pair x comma y belongs to F means y is equal to f of x. Then we say that y is image of element x under function f. Right? So if f from A to B is a function, then the set A is domain of function f. It's domain of f. And can you remember what is a range of f? What is the range of f? It is set of possible output of the function, right? So it is collection of elements of the set of output which are image of some element in the domain. For some element A in the domain, right? What is the codomain? Codomain of F is the set B, right? So then we can say that F is into function or a mapping A into B. So F is a mapping of A into B. Now my question is if F from my question is if I have set A with m elements and I have set B with n elements. So the question is how many functions F from A to B would be there. Right? So you can answer the question if you understand the definition of function clearly, right? So I have set A with m elements. How many elements are there? M elements are there. I have set B with n elements. And if F is function from set A to set B, how many functions would be there? So what is the basic restriction or condition? Each element of the domain should have unique image in the codomain. Right? That means what can be the possibility? If I have these two sets, so it may possible that all the elements can map to a single element, right? What case should not be there? One element of the domain should not have two images in the codomain. So it should not be the case. Except this, whatever the case would be there, no problem. Right? So this kind of case should not be there. This is the by definition of function, it is not true. What it says? For each element of the domain, there should be unique image, and in this case, if this thing happens, so in this case it is not a unique image, because if this is element X, so it has two images, and we cannot say that it is a rule or a function between the two sets, right? So if I choose one element from the set A, so how many possibilities are there? How many choices are there? How many ways are there to map this element in the codomain? So to map this element, I have n choices here. For other element, again I have n choices in the codomain. For next element, again I have n choices in the codomain. So for each element, for each element in the domain, we can have n choices in the codomain. And how many elements we have in the domain? We have m elements in the domain. right? So in all, how many choices we can have? For first element, I have n choices, and for second element I have n choices. For third element I have n choices. Similarly, for mth element I must have n choices. So m times this product of m times. So we can have choices to have a function f from A into B, right? Therefore, how many choices are these? I have written the product of n. How many times? M times. So it is n raised to m. Therefore, if cardinality of A is m, cardinality of B is n, then there are n raised to m functions from A into B. Right? The next thing is that